Hello and welcome back to Be a Learner. My name is Rakesh Suryavanshi and I am a solution architect who works with Accenture. Today we are going to discuss Kusto Query language. It's a complete guide session in which you are going to learn the query language, which will be helpful for the log analytics and the application inside. This course has a multiple demonstration, so each demo is going to be highlighted with the current state in the given highlighted section below. So you can keep track of the current section and navigate here and there if you wish to. Let's begin. This is the Microsoft documentation guideline for the Kusto Query language. In today's session, we are going to have the complete guide on the different operations of the Kusto Query language. We'll see what are the different key method functions which you can use to learn the Kusto Query language from the beginner. So if you are a beginner who do not have any idea about the Kusto Query language, this is the place for you to learn the Kusto Query language. If you are a beginner and wants to learn the Kusto Query language, you can use the URL which is aka.ms/lademo, which is a log analytics demo. Once you hit enter, it will redirect you to your Azure portal and you'll have this kind of a window. To run the query, you don't need to create any records. This will be here. You can run the query and produce a result based on some of the dummy databases. But conceptually, the same queries can be applied on the actual data as well. Let's begin and start some of the new query languages. So let's first of all understand different parts of the Kusto Query languages from the point of view of Azure. Here in this demonstration, we are going to use the log analytics query window. You can find this log analytics query window in your Azure resources. So if you open the log analytics and then go to the query or the alerts and write a custom query, then you'll have this kind of a panel. Here in this panel, each section, which is a preview section, is highlighting a separate database. For example, we have the Active Directory health check, the database for the logs of the Active Directory health check. We have the database called Azure Monitoring for Virtual Machine, SQL Central, and so on. We are going to use, in this case, in our demonstration, we are going to use log management for writing our queries. If I expand the log analytics database, you will see that we have the multiple tables here in this log management database. Each table is going to represent its own set of records, which will consist its own set of columns. If I expand alert table, you can see alert table has multiple columns which represents different set of data. For example, alert context, description, alert ID. If you look at the symbols carefully, the symbol T represents the text type of column. Symbol hash represents a column which is a type of numeric. And similarly, if I go down, a symbol which is a clock symbol represents a column is a type of date and time. By this way, you can recognize the type of column with the help of icon itself. The simplest query you can write in the log analytics. So let's say if I want to run any query on my performance table, which is under log management database, the simplest query I can write is perf and then hit enter. To run the query, you can either press Shift Enter or click on the Run button at the top. Here when I run the query, it returns a result based on the task for past 24 hours of time. If you wish, you can change the timeline based on the different time section, or you can specify the custom timeline as well. Once you have the query returned successfully, if you wish, you can store the query in the Query Explorer. Query Explorer is the place where you can store all your queries, and we can use it for the future use. There are some queries which has been given to you by Microsoft Azure, which you can use and customize for your own benefits. So this is one of the simplest query we have written just now to return everything from the performance table. As you can see, I've got everything which is available in the performance table from the last 24 hours of duration. It has returned all the columns and all the records. This is one of the simplest query we have. Another simple query which we can have is from the search column. We'll discuss in the search queries in detail. Just to give you an initial overview, if you write search and then the value of the search, this means that you're trying to search everything from all the databases. So it will try to search a keyword memory from all the database, all the columns. I'm not going to run this query because if I'm going to run it, it might take 30 minutes or so. This because it is going to be a very expensive query, as it is going to be searched in all the database in all tables. Now let's begin and go to our very first operations, which is the search operation. As I mentioned in the previous section, a very basic search operation you can write with this keyword search and the value. If you do not specify table name or the database name, then it will try to search everything from all the available database and tables. Next search query, which is much more optimized than the previous one, we can write is the name of the performance table. You can write it like perf, name of the table. As soon as you press enter, there will be a pipe character applied, and then after the pipe character, you can add the filtration. Something like where, or let's say search. Once you place search, you can say, okay, ops manager. And by the way, this is going to be this is not a case sensitive. If I'm going to run this query, I'll have last 24 hours of result, and it has returned 50 pages with 10,000 items of each. And this is now the case sensitive record. So even though if you are going to write lowercase, it should return all the records. This is one of the result of the search query. The name of the table, pipe character, name of the operator, which is the search operator, and the value, what you want to search. Now, it might possibly want to run search from the different multiple tables with a specific value. To write a search operation from a multiple table with the given value, you can write it like this: search in from which table you want to include, list of tables, and the value which you want to retrieve. Next, you may want to search any specific value from a specific column. To retrieve the value from the specific column, you can write name of the table, pipe character, search operator, name of the column, and the value which you want to retrieve. And this is how it will return the result. You can see that I have got all the records which has the counter name available megabytes. This is again one of the example of the search query. Next, in the previous example, when we search with the exact match, a value which is matching with the exact. But what about if you want to retrieve the value which is not the exact match, or what about if you want to match the word or a specific text within the entire sentence or entire text? I'm referring the like operator if you are familiar with the SQL Server. To write the like operator or find out a specific text within the column, then you can write name of the column and then apply the column character and then the value. If I do so, I should have the value. So it will search m bytes in this column and it will return. You can see that I've got everything which has got m bytes, even the available byte as well as the available byte memory. Next, if you want to retrieve the search from all the columns, you can write it like this. This will try to search m byte from entire table in all the columns. Let's search now with the help of wildcard search. To run the wildcard search, you can use star character either before or after, and then run the search query. It should return everything which is starting and ending with m bytes. I got the same result. Now if you want to have the search result which is starting from bytes, you can use the start with operator from everywhere. So basically this query is going to search from all the columns the value which is starting with bytes. Let's see what is the result we are getting. You see that I'm getting the result from everywhere which is starting from all the byte, and this time the counter name is counter name starting from the bytes. Same, if you want, you can use the ends with, and the ends with will return everything which is ending with the byte. Next, if you want, you can use the search in between, which is starting with some fixed set of character and ending with some fixed set of character, which is given in this particular example. So if I run the query, I should get the result which is starting with free, have some value, and then it returns the bytes at the end. So you can see 3 megabytes is the result. Now you can combine the logical operators in the search operator as well. For example, if I want to search everything from the performance, which includes free bytes and logic or D, let's see what would be the result. So we are searching here 3 different things. We are searching either any column has the value logic, or the column has value D, or column value has free, starting from free and ending with bytes. Similarly, you can use the search operator with the regular expressions as well. To use the search with the regular expression, you can use the name of the table pipe character, name of the operator, which is the search operator, name of the column, and then use matches keyword for the table expression, followed by regex, and then the value of your regex. In this case, I'm trying to find anything in the instance name column which starts with A to Z character and it has fixed set of column. After that, let's see what would be the result we are getting. As you can see, instance name has got the value which is starting with a single letter, and then after that it has a column. This is about the search operator. You can use any combination of these operations with the search query and get your desired result. I hope this was helpful. In the next session, we are going to look at the where query. Now let's discuss about the where operator. With the where operator, you can basically apply the filtration on the result set based on this specific column. It is similar as the search query. To use the where operator, you can use it like name of the table, pipe character, and then the column name. And here I'm using greater than with the ego aggregated function or this ego scalar function, and then applying the value as in hour, second, or the minutes. So at the moment I'm trying to retrieve all the records of which are generated 1 hour ago. Let's see what is the result we are getting. Similarly, the echo function can accept the values like for the day, it can have the values like D, for the hours, H, minutes, second, ms, millisecond, and microsecond. It can have the microseconds as well. Now, where operator can be combined with the multiple operands with the logical operators like AND or OR. So to use the logical operator with the where condition, you can use it like the name of the column, comparison, and then logical operator which is AND or OR not equal to or equal to, whatever you want, and then you can use the comparison with the help of multiple operators. You can also use the where operator with the combination of AND and OR both. Like in this query, I'm trying to retrieve all the records which are generated 1 hour ago, and also the counter has the byte received second, or counter has the percentage performance time, and counter value is greater than 0. Let's say if I'm getting the record. As you can see, I can use the where operator easily. Similarly, here in this case, comparing to the previous query, here in this case I have two where clause. One where clause is the same as previous, wherein I am applying multiple where conditions, and the result of whatever is the result of this where clause, on top of that result I am applying another where condition and retrieving the value. This is how you can use the where on top of where, or basically you can compare it like SQL nested query, wherein this is one of the inner layer query which is returning the result, and on the result of the inner layer query I am again applying the operators like where. Similarly, with the help on the where operator, you can apply some of the other functions such as has prefix, which will search everything which has prefix called byte. Let me run this and see the result. As you can see, it has searched for everything which has the byte character or byte word in it. Similar to that, we have the has suffix function, and also we can apply the contains function with the where operator. Next, you can use the where condition with regex like we have used with the search. So result will be same as we have received with the search. Here I am applying the first place, we are applying the where condition, and whatever is the result on top of that I am applying the take conditions. Basically it will retrieve all the records from this condition, and then it will retrieve top 10 from that. This was about the where condition. Next, we are going to discuss about the take query. In this section, we are going to look at how do we use the take query. Take query can be used to retrieve or take the record, take the specified number of record from the given table. For example, in this case, I am trying to retrieve 10 records from the given table. This returns the result, but the problem with the use of take result, it does not guarantee the same set of result at the next time. So if you are lucky enough to get the same result, you will get it, but it might possible in the next run you might not get the same result because text runs on the different operators. Next, you can also use the limit operator as well in place of take. Take and limit both works in the same set. So if I now run the limit, it will return the same set of result record. Not same, but basically it will return the 10 records only. Now let's discuss about the count operator. With the help of count operator, this is the count operator. Similarly, we have the count function as well, which we will discuss it later. But this is the count operator, or the count condition basically, which you can use to count the overall number of records within the table or within the specified condition within your query. For example, in this case, I want to count total number of records available in the entire table. So let's see what is the result we are getting. So we got the 4 million plus records in the performance table. Next, as I said, count can be used as a nested query as well. So here we are running the where operation, which has the multiple condition, and whatever is the result, we are retrieving the count on that result. So if I run the query, I'm getting the result as a 5228, which is the count on these particular where condition. Now let's look at one of the most important operation, which is the summarize operator. Summarize operation basically aggregate function or a group by function. Summarize operation can be used like summarizing the result set with the help of group by function. So like in SQL, you have a group by. So here with the combination of summarize and by, you can return the group by result set. So like if I want to return all the records from the performance table, and I want to count by the counter name column. So if I return the result, let's see what we get. So if you see that, this is what the value we are getting. So the record counter name, which has the value disk read per second, it has count this. So this number of records in this column has got the value disk reads per second, right? So it's the same as the group by function. Similar to that, this is just the same function but the only difference is we are applying the by operator or the group by condition on the multiple columns. Here I'm using the counter name and object name. One more difference, if you observe carefully with the previous query, the result of the previous query, which is the count, has the anonymous name or the alias name. To get the alias name on your query set, you can specify the name of the alias with the help of equal operator. So if you specify your alias name, any alias name like performance counter equals the count, so your value of the count column or the count column name would become perf counter. Let me show you how it looks like. Now you see you're getting the two group by column values and the count value, which is alias with perf counter. Now let's look at the summarize with the multiple function. In the previous example, we have used the summarize with the single function, which is the count function, but we can also use the summarize function with the multiple scalar function such as a count, average, or any other function. So in this example, we are trying to use summarize with count and average. Let's see what is the result we get. This is what the value we are getting, which proves that the free space in the table, which has the counter name value as percentage free space, these are the number of aggregate value for the counter value column on those records, and these are the total number of counts for those values. Next, we can also use the bin operator. Bin operator allows you to summarize into logical groups like days. For example, if I want to retrieve all the entries and then summarize into time generated from the last day, then this is what the query you can write. And by doing so, you will expect to have this kind of result. Bin can be also used to retrieve logical groupings. Next, let's look at the extend function. Extend function basically helps you to select the custom column or the defined custom column. Like in SQL, you calculate any column or the create any calculation on your select query, and you give a alias name or the column name to your query, and then you return the column name. So similar to that, with the help of extend function, you can retrieve the calculated column, and then that column can be part of your result set. So just to show you here, in the performance table, I'm trying to apply the where condition in the counter name, which is starting with free memory, and for memory I have just written ME, and here we are trying to extend the value or calculating the value with the help of counter value and by dividing the counter with 100 we are saying okay, it's going to be free GB and then MB, and then it's going to be, let's say, KB. So if I run the query now, this is what the result I'm expecting. So here we are saying, okay, this is the based on the counter value. I'm saying this is my total free GB space in MB and GB and KB, right? So this is how you can use the extend column. And this is not only to the mathematical operation, but if you want, you can apply the or use the extend column on the string column as well. For example, here in this particular case, we are using the extend column, creating the custom column, and here we are running the scalar function, which is the string concatenation function. We'll look at this scalar function in the separate section, but just for the information, this is the string concatenation scalar function, which will concatenate the two strings or the multiple string values and return the result. So you can apply the extend function like this as well. Now let's look at the next command, which is the project command. Up till now, we have seen that any queries or the operations which we have performed, it is returning all the columns from the given table. But we haven't seen any specific column or any specific operations which enables you to return any specific set of column or the subset of the column from the given table. To retrieve the subset of the column from the given table, we can use the project command. Here in this case, from the performance table, we are projecting these three columns: computer, counter name, and counter value. So the result set will ignore all the column apart from these three. This took at least 10 seconds and returned the result what we are expecting. Similarly, here in this case, what we have done, we have applied the multiple queries or the nested query. In the first query, we are returning the project with three columns, and then on top of that, we are applying the extend query, which is the outer query. So on the result of the project column, which would be these three columns, we are applying the counter value and retrieving the free GB, this available memory space. This will also return the same thing. If you don't want to use the extend, you can use the same thing, return the same result set with the project itself. Next, or the subset or the subquery of the project family is the project away. Project away is just the opposite of the project command. So if you want to take away certain columns from your result set, you can specify those listed columns here in the project away. Those columns will be ignored by your query set. This is how you can use it. So I'm not getting counter path and underscore resource ID in my result set. Similarly, you can use project name or rename, and you can rename a specific column and return as per your abbreviation which you want. For example, in this case, I've renamed the computer name to my VM, and this is what the result I'm getting. Now let's discuss about the distinct operation. Distinct operation allows you to return the distinct value or a unique value from the given table. So you can use the distinct operation with the combination of column within the given table like this. So if I run the query, this should return all the value generated within last 1 hour and which is distinct amongst object name and counter name. If you look at the value, we have got the K8 container memory working. We have got the K8 container restart. So combination of both is unique. Even though the object names are repeating, some of the counter names are also repeating, but the combination of both in the same row is not repeating, so it's unique. And this is what the distinct function allows you to do. I hope this was helpful, and by having this query in place, you should be able to write some of your own Kusto Query language to return it or to run it in your log analytics or in the application inside. If I open some of the queries which is given by the Microsoft, let's see what values we have. This is what the simplest query we are getting. Now looking at these queries, you should be able to understand what they are trying to do. Let's walk me through on this particular query. So we are running the where condition, give me all the record which are generated in last 1 hour on the performance table, and on top of that run the compute, filter a record on the column which is start with consuso, and again on top of the result apply again a where condition on a column, this time on column counter name which has value megabyte, and on top of the result apply a summarize count by so that it returns the group by operation based on the timeline and the name of the computer. And once you have the values, render the chart. Let me run this query. Seems like we do not have the time range specified, so let me see if we can run this query. In this last 24 hours we do not have anything available, maybe the name of the computer. I'll remove the condition, name of the computer, and let's see what we got. This is what the chart we are getting. Because we do not have any computer name with the control, so I have just removed the condition. I can here go and change the chart as well. Once you have these nice queries, what you can do here, you can pin to the dashboard, save the query and pin to the dashboard, and it will be available on your Azure portal dashboard, something like that. If I go to the dashboard, here, so it will be available here. Let me find out some of the complex query. So let's see, we have got what we have got. I hope this was helpful. Thanks for watching it. In the next section, we are going to look at the scalar function. Till then, bye. Please do subscribe the channel and hit the like button if it helps you. Thank you very much.